Picture a local primary school. It's parents' night, right?
Oh, boy.
Yeah, you can already imagine it. The teacher is up at the front going over the curriculum for her first-year students, and afterward, two different fathers approach her.
Okay.
And the first father, Philip, he is intense. He leans in and tells the teacher that his 6-year-old son has tested as bright, and because of that, Philip expects him to master reading, addition, paragraph writing, all by the end of the year.
He wants a return on investment.
Exactly. An immediate, measurable academic return on his kid's innate intelligence. But then the second father, Sam, walks up.
Yeah.
And Sam is also intense, and his son has also been labeled as bright by those exact same early intelligence tests.
But a different approach, I'm guessing.
Completely. Sam says, I just want him to have a normal childhood. He's only 6. Like, the hard work will come later. I want him to have fun.
Wow. Yeah, two completely different blueprints for raising a human being.
Right.
And both are based on the exact same starting material.
Which perfectly sets up our mission for this deep dive. Today, we are taking you into honestly, the fascinating world of human psychological development.
It is such a huge topic.
It is. We are looking at a really comprehensive stack of source material that covers the ultimate journey, like how we become who we are.
Yeah.
We're exploring that massive and sometimes completely baffling transition from a totally helpless newborn to a complex adolescent.
And untangling that eternal dance between nature, our biology, and nurture, our environment.
Exactly. Because Philip and Sam, they encapsulate how our own expectations fundamentally shape the nurture we provide. So, okay, let's unpack this.
Well, to really get to the bottom of how nature and nurture interact, you kind of have to rewind the clock to the absolute beginning of life.
The very beginning.
Right.
Yeah.
Historically, 17th century philosophers pushed this idea that newborns were a tabula rasa.
A blank slate.
Exactly, a blank slate. The assumption was that a baby arrived with zero built-in knowledge. Like, every single trait, fear, or preference they developed was just written onto that slate by their experiences in the world.
I mean, it sounds poetic, but reading through our sources, modern psychology completely dismantles that myth.
Completely.
Like, we now know a newborn infant enters the world with an estimated 100 billion neurons in their brain.
100 billion.
Hmm.
And while there are relatively few connections between those neurons at the exact moment of birth, the brain is going to triple in weight in just the first 3 years of life.
Triple in 3 years. That's insane.
Right. And that weight isn't from new neurons. It's from this absolute explosion of connections being formed between them as they interact with their environment.
It's like, think about your own smartphone. When you buy a new phone, it doesn't come as a blank hard drive waiting for you to code it from scratch.
No, of course not.
It comes preloaded with an essential operating system and a bunch of vital, undeletable apps right out of the box. And a newborn's brain is working on a very similar principle.
And what's fascinating here is that those preloaded apps are strictly designed for two things: survival and social bonding.
Just those two.
Just those two. The hardware is incredibly specific. For example, newborns have terrible visual acuity. They are extremely nearsighted.
Everything is just a blur, right?
Basically.
Yeah.
But they're actively scanning the world, and they are already wired with visual preferences. They seek out areas of high contrast. They prefer patterns with curved lines over straight ones.
And faces.
Yes. They have an intense baked-in preference for looking at faces.
But not just any faces, though. The research points out they prefer to look at normal, structured faces rather than scrambled features. Though, interestingly, at birth, they don't actually have a preference for the faces of their own race or culture.
Oh, that's true. The software update for that doesn't happen until they hit about 3 months old.
Which is when they start showing a clear preference for faces of the race they see most often in their environment, right?
Exactly, which is the perfect illustration of how the hardware and software interact. The hardware comes ready to process faces, so that's the nature.
Right.
But the environment, the nurture part, quickly trains the brain's algorithm on which faces are most relevant for survival.
That makes so much sense.
And it goes way beyond vision, too. I mean, their senses of smell and taste are highly functional out of the box.
Right, the breast milk thing.
Yeah, a breastfed infant after just a few days will consistently turn its head toward a pad saturated with its own mother's milk over another mother's milk.
Wow.
And they inherently prefer sweet tastes. They'll actually physically scrunch up their faces in disgust at bitter ones.
Okay, but we have to talk about their hearing because the fetal memory study in the text was an absolute aha moment for me.
Oh, the cat and hat study.
Yes. So researchers had pregnant women read aloud the Dr. Seuss book, The Cat in the Hat, every single day during the last 6 weeks of pregnancy. Then, just days after the babies were born, they wanted to see if the babies actually remembered it. But, how do you test a newborn's memory?
You can't just ask them.
Right. So you give them a special pacifier hooked up to a computer that records their sucking rate.
It is an incredibly ingenious piece of developmental research. Since babies can't answer a questionnaire, you have to measure the one physical mechanism they actually control.
Right, the sucking. So the babies quickly figured out that sucking on this pacifier in a specific rhythm would turn on an audio recording.
Yeah.
And they intentionally altered their sucking rate just to hear the cat in the hat, the exact story they heard in the womb, rather than a new, unfamiliar story.
It's amazing.
And the craziest part is they preferred the rhythm of that specific story, even when it was being read by a total stranger.
Wow.
Like they remembered the acoustic cadence from before they were even born.
It completely shatters the blank slate theory. I mean, they are downloading information and processing the world before they even take their first breath.
So if the newborn is this preloaded sensory powerhouse, how do they move from just taking in sights and sounds to actually understanding the physical world? Like, how do they upgrade that operating system?
Well, the old developmental models used to view kids as passive sponges, right? Just soaking up the world.
Yeah.
But modern psychology flipped that. Children are now viewed as active participants. They are essentially inquiring little scientists running constant experiments on their environment.
Oh, I've seen this. If you've ever watched a toddler sit in a high chair and deliberately drop a spoon onto the floor 50 times in a row,
Yes.
they aren't just trying to break your spirit. They are running a physics experiment, like gravity check, trial 51.
That is exactly the mechanism. Through these tiny experiments, children build what early psychologist Jean Piaget called schemas.
Schemas.
Yeah. A schema is basically a working theory of how the world operates. When a child encounters something new, they try to force it into an existing schema. That process is called assimilation. But if the new information flat out contradicts the theory, they have to rewrite the code. And that is accommodation.
The sources give a fantastic example of this, actually. Imagine a young boy whose schema for a firefighter is exclusively a large adult male in bulky gear.
That's his whole database for the concept.
Right. And one day, he sees a picture of a woman in a firefighter's uniform. At first, he tries to assimilate this by thinking, oh, she's just playing dress up.
He protects his existing theory.
Exactly. But as he sees more evidence of women actually fighting fires in the real world, his brain is forced to do the heavy lifting of accommodation. He permanently alters his operating system to accept that women can be firefighters too.
It is a highly efficient mechanism for learning. But, for all time, the prevailing wisdom was that this development happened in very rigid, universal biological stages.
Right, like Piaget thought.
Yeah. For example, it was long believed that infants under 8 or 9 months old completely lacked object permanence.
Which is the understanding that an object continues to exist even when you can't see it.
Exactly. The classic test was showing an infant a toy and then throwing a cloth over it. The infant would stop reaching and look away, as if the toy had literally vanished from the universe.
Poof. Gone.
Right. So the conclusion was that their brains just hadn't matured enough to grasp hidden objects.
Wait, hold on, though. The idea that a baby thinks a toy literally pops out of existence just because you put a blanket over it, that feels like a massive leap.
It does, right.
Couldn't it just be that pulling a blanket off a toy is physically hard? Like maybe they know the toy's there, but their motor skills and coordination just aren't advanced enough to plan out the rescue mission.
That exact skepticism is what drove later researchers to design the rotating screen experiment, which completely rewrote the timeline of cognitive development.
Oh, I love this one.
Instead of making the babies physically reach for something, they just tracked their eye movements. They took 4.5-month-old infants and showed them a screen that sat flat on a table and then hinged upward to rotate back and forth in a 180-degree arc. Eventually, the babies got bored watching it flat back and forth.
Which establishes the baseline.
Right. Then the researchers placed a solid box behind the screen. They showed the babies 2 different events. In the possible event, the screen rotated up, bumped into the hidden box, and stopped.
Makes sense.
But in the impossible event, the screen rotated up and then magically kept going, appearing to pass right through the solid box, which was achieved through a hidden trapdoor.
And the babies stared significantly longer at the impossible event.
Yes.
They were surprised. They knew the solid box was supposed to be there blocking the screen, even when the screen hid the box from view. They had object permanence at 4.5 months old.
Proving that earlier tests severely underestimated children's cognitive software.
Yeah.
It paved the way for alternative theories, like the knowledge acquisition view. This view argues that kids don't necessarily have fundamentally different types of brains than adults.
They just have a smaller database of facts.
Exactly. The textbook cites an incredible study comparing 10-year-old chess experts to 18-year-old college students who were chess amateurs.
Oh, the 10-year-olds had vastly better memories for the chessboard layouts than the college students.
Which is wild.
And it wasn't because their brains were biologically superior at memory tasks in general, but because they had deep domain-specific knowledge. They could chunk the information into meaningful patterns.
Other researchers, like Lev Vygotsky, point out that learning isn't just a solitary scientist in a lab. It's more of an apprenticeship.
Right.
Children learn through guided interactions with more knowledgeable people, and they use language to actively write their own mental software.
Which is why you see young children talking out loud to themselves while doing a difficult task, like tying their shoes.
Yes, exactly.
They're using private speech to verbally guide their own actions until the process becomes automatic.
It's all part of the upgrade process.
Okay, so if upgrading the physical software involves schemas and impossible boxes, how do they figure out the social world? Like, to go back to our smartphone analogy, how do they install multiplayer mode?
I like that.
How do they realize that the person sitting next to them has a completely different mind with different thoughts and beliefs?
Well, psychologists call this the theory of mind. It is the profound realization that other people have independent mental states.
Okay.
The classic way to test this is the false belief task. You show a 5-year-old a recognizable candy box and ask what's inside. They say candy. Then you open it and, surprise, it's filled with crayons.
Which is a cruel trick to play on a kid.
Absolutely. But then you close the box and ask the 5-year-old, when your friend walks in the room, what will they think is in the box?
And what do they say?
The 5-year-old will laugh and say candy, because they understand their friend has a false belief.
Yeah.
They can model someone else's mental state.
Right.
But if you do the exact same test with the 3-year-old, the 3-year-old will confidently say their friend will guess crayons.
Because the 3-year-old knows it's crayons, and they assume that whatever they know, everyone in the entire world must also know.
Exactly.
Their operating system can't run two conflicting mental models at the same time yet.
And developing this theory of mind is the critical stepping stone to moral judgment. Once you understand others have separate minds and feelings, you can begin to evaluate right and wrong.
Oh, okay.
Earlier theories map this out using moral dilemmas, like Lawrence Kohlberg's famous Heinz dilemma.
That's the one where a man's wife is dying, and he can't afford the extortionately priced life-saving drug, right?
Right. So he breaks into the pharmacy and steals it.
And the researchers weren't interested in whether the kid said stealing was right or wrong, but why they thought so.
Exactly. The reasoning reveals the software version they are running. At the pre-conventional level, typical of young children, morality is entirely about avoiding punishment. Heinz shouldn't steal because he'll go to jail.
Simple cause and effect.
Yeah. At the conventional level, usually reached by early teens, the software updates to focus on social rules and group approval. He shouldn't steal because stealing is against the law, and laws keep order.
Okay, makes sense.
Finally, the post-conventional level evaluates actions based on abstract human rights. Heinz was right to steal because human life is inherently more valuable than property rights.
But just like with the hidden toy test, modern research suggests those dilemma tests might have relied too heavily on a child's ability to verbally explain themselves.
Very true.
Because our text talks about a study with infants who were just 6 months old. They watched a puppet show where a helper shape pushed a ball up a hill and a hinderer shape aggressively pushed the ball down the hill.
Right, the puppet study.
Afterwards, the babies were presented with both shapes on a plate, and the 6-month-olds overwhelmingly reached for the helper shape.
They liked the good guy.
Yeah, so I have to ask, if a 6-month-old can already spot the bad guy in a puppet show and actively avoid them, doesn't that imply that a rudimentary sense of justice is baked into our DNA long before we can even speak?
If we connect this to the bigger picture, it strongly suggests an evolutionary preparedness for altruism. Mammals survive by cooperating in groups.
Right.
We might be pre-wired to prefer cooperative behaviors and reject antisocial ones because that preference literally keeps the species alive.
Wow.
But this naturally leads us to ask, if basic morality is partially innate, how much of our unique individual personality is pre-programmed out of the box, and how much is shaped by our parents?
Ah, the ultimate nature versus nurture battleground.
We start with temperament, which is essentially the mood-related baseline of personality. The data shows temperament is largely inborn.
Okay.
Babies generally fall into three categories: easy, difficult, or slow to warm up. But a child's innate temperament interacts heavily with how their parents respond to them. And that brings us to attachment.
And when we talk about attachment, the sources highlight those famous, somewhat heartbreaking mid-century experiments with infant monkeys.
Harry Harlow's work.
Yes. For a long time, the prevailing wisdom was that babies attached to mothers simply because mothers were a food source. It was viewed as purely transactional.
Right.
But researchers separated infant monkeys from their mothers and put them in an enclosure with two artificial surrogates. One was made of bare, uncomfortable wire, but it had a bottle of milk. The other was covered in soft, cuddly terry cloth, but provided absolutely no food.
And if the transactional food theory was right, the monkeys should have bonded with the wire mother.
But they didn't.
No, they spent practically all their time clinging to the terry cloth mother for comfort, only reaching over to the wire mother when they were desperately hungry.
It proved that contact, comfort, and physical nervous system regulation are fundamental biological needs, like completely distinct from just getting calories.
In humans, researchers measure this security using a protocol designed by Mary Ainsworth called the strange situation. It involves a mother and a baby in a playroom, a stranger entering, the mother leaving, and then the mother returning. The crucial data point isn't how loud the baby cries when the mother leaves, but how the baby acts when she comes back.
Okay, so what do they look for?
Well, securely attached babies might be upset when mom leaves, but they seek her out and are quickly comforted when she returns, using her as a secure base to explore.
That's the ideal.
Yeah. Then you have insecurely attached avoidant babies who largely ignore the mother when she comes back, as if they've learned not to rely on her.
Oh, sad.
And insecurely attached ambivalent babies will simultaneously seek comfort but angrily resist it, crying to be picked up and then squirming to get down.
But the textbook is very careful to point out that we cannot project Western standards universally here. Like, cultural context is everything.
Absolutely.
For example, Japanese babies rarely leave their mother's sides in daily life. So when they are thrust into this specific laboratory test and separated, they score exceptionally high on anxiety.
Which is totally understandable.
Right. But that doesn't mean they are insecurely raised. It just means the test itself is uniquely terrifying based on their cultural norms.
Exactly. Which brings us to one of the fiercest debates detailed in our sources. Does parenting really dictate how a child turns out in the long run?
Oh, boy.
There are two very prominent camps in psychology. One camp, championed by Judith Rich Harris, argues that parents actually have very little lasting influence on the adult personality or intelligence of their children.
Really? None?
They point to data showing that siblings raised in the exact same home are not noticeably more alike in personality than strangers. This camp argues that the outside environment, and specifically the peer group, matters most.
And the prime example they use is language. Children of immigrants will almost always speak the language of their peers, without a foreign accent, regardless of what is spoken at home.
Because evolutionarily, you don't need to fit in with your parents' generation to survive. You need to fit in with your own generation.
That makes a lot of sense.
You adapt to the outside world, because that is where you will compete for resources and eventually find a mate.
So it's essentially a debate over whether parents are the master architects of a child's personality, or if parents just provide the plot of land while the outside world and peers actually build the house.
That is a perfect way to frame it, because the opposing camp, led by researchers like Jerome Kagan, counters that parents are instrumental in laying the foundation.
Okay, so what's their argument?
They argue that parental affection, social class, and how the child interprets their parents' actions create the scaffolding for how a child views the world. A family's social class, for instance, heavily dictates a child's sense of agency and what opportunities they believe are available to them.
I mean, both are compelling arguments, but whether you believe the parents or the peers hold the steering wheel, there is one universal biological software update that flips the script entirely.
Adolescence. Puberty is a massive physical and cognitive earthquake. Psychoanalysts like Erik Erikson define adolescence as the ultimate search for identity. It is a period of intense role experimentation, figuring out who am I and where am I going.
Here's where it gets really interesting, though, because if you've ever interacted with a teenager, you know it's not just a philosophical search. The physical brain is undergoing a bizarre structural disjunction.
Yeah.
The text describes the teenage brain as being all gas and no brakes.
That's very accurate. When you look at the brain development, the areas involved in emotion, reward, and motivation, specifically the amygdala, mature very rapidly in early adolescence.
Okay.
They become highly reactive to social stimuli and dopamine rewards.
Hmm.
But the frontal lobes, which are responsible for cognitive control, long-term planning, and impulse regulation, are still heavily under construction.
Which explains so much. You have a brain that feels everything intensely, craves social reward from peers, and has absolutely no hardware installed yet to hit the brakes.
Right.
And from an evolutionary standpoint, that actually makes sense. Historically, a young human needed a massive burst of risk-taking dopamine to overcome the fear of leaving the safety of their family to go out and find a mate or new territory.
If the rational, cautious brain was fully in charge, they'd never leave the cave.
Exactly. But today, the textbook highlights how the internet acts as a massive magnifying glass for this specific biological vulnerability.
This raises an important question about how we manage the digital environment. The internet is a profound double-edged sword for a brain craving social reward.
Totally.
On the negative side, it amplifies risks tremendously. Teens are vulnerable to online predators, and there's deeply concerning data about troubled teens finding echo chambers that normalize maladaptive behaviors, like self-injury or disordered eating.
It effectively outsources their peer group to the most extreme corners of the web.
Yes.
But the sources also highlight immense benefits, which we really can't ignore. When African American teens in one study were given home internet access, their standardized academic test scores improved over 16 months. Wow.
And the internet can provide crucial destigmatized health interventions, too. The text details a web-based program called Hip Teens that helped overweight teenage girls evaluate their food intake and communicate safely with counselors.
Oh, that's great.
And it resulted in significant health improvements compared to a control group. So it's an incredibly powerful tool. It just happens to be handed to a demographic that is biologically overclocked to take risks.
It requires a delicate, constantly shifting balance of supervision and freedom, and it circles right back to that core theme: a biological brain maturing within a highly specific, rapidly changing environment.
So what does this all mean? We have traveled from a newborn whose smartphone-like brain is preloaded with sensory apps for survival, to a toddler acting as an inquiring scientist testing the physical code of the world, to a teenager navigating a volatile hardware upgrade driven by peer relationships.
It's quite a journey. It really is. The core takeaway from all these sources is that human development isn't just nature, and it isn't just nurture. It is a constant, inextricable feedback loop between the genes we inherit and the world we interact with.
You truly cannot separate the software from the hardware. They build each other.
Which leaves me with a final thought for you to chew on. If our psychological development is so deeply shaped by adapting to our specific cultural and social environment, how will the rapid integration of artificial intelligence and purely virtual realities fundamentally rewire the cognitive and social development of the next generation of children?
That is a wild thought.
Right. If a toddler spends their developmental years pushing boundaries on a tablet, will they develop a theory of mind for AI? Will they expect the digital world to have its own beliefs and desires?
Wow.
It makes you wonder about Philip and Sam, those two fathers at Parents' Night. Maybe the question isn't whether to push a child to read early or let them play, but how to prepare a human brain for a world that is evolving faster than our biology ever could. Thanks for joining us on this deep dive.